Hey everyone, today we're going to be looking at the Chapter 11 practice test, problems 1 through 4. Now this is unlike the ones that we had previously been doing where it's one long sustained problem. And even though this is going to refer to the same problem setup, these are meant to be shorter questions. But you're going to see these are kind of similar, kind of for economy's sake really. So let's go ahead and take a look at what we have going on here. We've got two categorical variables, A and B, and they are thought to be related. Now a survey was taken and the results are shown below. So this is a really context-free kind of a problem. You'll also notice that there are 3 rows, 4 columns. So that's a total of 12 things to compute if we are going to do a chi-square, any kind of chi-square procedure. And that's a lot, more than we would normally do. So I think we're going to concentrate mostly on calculator procedures for this particular problem. So let's go ahead and figure out what things we're going to be doing here. We've got what kind of chi-square test is appropriate for this data. That's certainly indicative of a chi-square test for association. Like we said before, there are 3 rows and 4 columns, so for the degree of freedom, where we have the number of rows minus 1 multiplied by the number of columns minus 1, we would get 3 minus 1 multiplied by 4 minus 1, which is just 6. Next, we're going to create our table of expected values. Now, I promised you we were going to do this with a calculator, and I'm not going to go back on that. Let's grab our calculator. For a chi-square test for association and a chi-square test for homogeneity, you're going to want to go to the matrix menu. So I'm going to click matrix, and I've got a few matrices already here. But the command that I want to go to is, I kind of move this over too much, but I want to go to the command that says edit. I'm going to scroll over to edit, and now I got to select which of these matrices I want to edit. And the one that we're going to use is matrix A. Let's change matrix A. We know that we have 3 rows, 4 columns. And that will get our matrix set up in the correct dimensions. Now we're just going to enter in all of our values here. 12, 13, 34, etc., etc. Once you've got your matrix set up, you're going to go back to the home screen. And this is a super shortcut way, but we're going to go to Stat, Test, and then we're going to scroll down until we get to the chi-square test. Now, because the chi-square test for association and the chi-square test for homogeneity are mechanically the same, our calculator has kind of collapsed them into the same test here as just the chi-square test. You would use this for both homogeneity and the test for association, like we're doing now. It's really nice. It only asks for 2 things, 3 things if you count color for draw and etc., etc. But the observed matrix is A, and I wouldn't mess around with it. I'd leave that at A. The expected matrix is going to be in B. Now, I know what you're saying. We never made an expected matrix, but that's the secret here is the calculator will make the expected matrix for you. So when it says expected B, it's really saying, where do you want me to put the expected matrix? So where can I find the observed matrix? Where can I find the expected matrix? And I'm a big fan of draw because I like seeing the chi-square curve and the test statistic involved. So I'm going to click draw. You could also do calculate. You just wouldn't get the picture of the chi-square curve. So let's draw. Let's see what we get. All right. This is a very typical looking chi-square curve. Right skewed. And we don't see the p-value at all. It's very small. Probably just at the very end there, shaded in. So here's our chi-square test. We get a chi-square test statistic of 24.6837, and we have a p-value of 0.0004. So all this stuff we're going to take note of. I'm going to screenshot this and bring it back to my work. But wait a minute, we were looking for the table of expected values. So to get the table of expected values, we would go back to the home screen, go back to that matrix menu, and now take a look. I don't know if you noticed it, but matrix B had dimensions 3 by 2 earlier, and now it has dimensions 3 by 4. So the calculator has manipulated or overwritten matrix B with the matrix that is the expected matrix. As always, I like to go to Edit because I don't feel so rushed here, and here are all of the values for the expected matrix. Now I'm going to take a note of these and I'm going to put them down into our work now. And then there we have it. This is our expected values with as little fuss as possible. You don't really need to round these to too great of a degree of precision here. My rule of thumb is always 1 decimal place more than the data that's presented. So, if we're looking at things in whole numbers, then my expected values, certainly I should be okay if I just go to the 10th place. Okay, how about that chi-square test statistic? Now, we don't want to get too carried away and not show any work at all. So I do recommend you show something here. Start off with the specific formula here for this chi-square test statistic. Maybe write in the first 3 contributions to the chi-square test statistic and the last contribution to the chi-square test statistic. That should be plenty of work to satisfy. Then, of course, remember our printout. We found that the chi-square test statistic was equal to 24.6873. There's a p-value there in our printout also, but we don't need the p-value for this particular problem. And let's finish up here with question number 4. Which of these cells contribute the most to the chi-square test statistic? Now, this is a not difficult question, but for this question, you're going to have to actually look at all of the chi-square contributions. So we're going to try to shortcut this a little bit, again, with our TI calculator. So let's grab our calculator. And this time, instead of going to the matrix, I want to go to the lists. Now, you're going to put all of the observeds in list 1. Pay attention to the order in which you put the observed matrix in list 1, because you're going to need to match that. Once your observed are in L1, you're going to put all of the expected in L2, keeping that same order that you put the numbers into L1. Now again, it's very important that your lists correspond. So for example, this very last one, I have the expected is 21.7 and the observed was 15. And those two match position-wise. This one over here is 19 and 21.9. If we go back to this, we got 19 is B2A1, 21.9 is B2A1 as well. So they do need to match in position. Now to shortcut this so that you don't spend all day calculating things, you're going to go to the top of L3. Please notice that L3 over here is kind of highlighted, although it's in black, but it's highlighted. I'm going to push enter and notice that the cursor starts blinking down over here, which means I can start typing in a formula. And it's going to be the same formula for the chi-square test statistic. It's going to be L1, which is the observed, minus L2, which was the expected, squared, and then divided by the expected, which was L2. And once you push enter, it's going to populate L3 with all of the chi-square contributions. If you added the entire list of L3 together, you would get your chi-square test statistic. So which of these are the biggest contributors? It looks like 4.5, that's 4.50. Here's 4.58. Anything bigger than 4.58? No, 4.58. So 4.58 corresponds with, what is this? 34 and 23. So where is 34? 34 is B1A3. So which cell contributes the most? B1A3 contributes the most to the chi-square test statistic. It contributes 4.58 to the chi-square test statistic. So that is the first, not even really the first 4 questions, but it's questions 1 through 4 on your Chapter 11 practice test. Good luck to you. We got one more of these videos to go, and we'll see you at the next one.